I think most of us already know you, but pleasure to welcome Philippe to give us a talk. Philippe is now at Microsoft Research. He does a lot of work on reading, writing interfaces, and also LLM benchmarking. Some of the papers we looked at together are in sync. And then Sergey and I also did a brief overview of your paper in one of our team meetings around the answering engine one. So Philippe, why don't you take it away?
Yeah, awesome. Thanks, Joseph. It's a real treat to be talking with you guys. I hope that folks online, you can hear me well. And I've been telling my wife the whole time, I can't wait to give this talk at AI2. I can't wait for the talks afterwards and kind of exchange of ideas, because I think you guys do some of the best work in this space of the reading and writing interfaces with LLMs. And so, yeah, let me share some ideas. So at a high level, this is how I kind of represent my work. It's called the Research Garden. So I work mostly, from my PhD onward, I've worked mostly on reading interfaces and writing interfaces. And they're both basically things that involve deeply NLP because of text being at the center of it all, and then HCI, the interfaces bit. And if you squint, I say summarization can be seen as a kind of reading interface. So I kind of club the first two flowers as reading interfaces. And today I've prepared this, what I call the 3-course meal. The garden is like some sampling from the most recent work, and that includes. I wanted to start with the work on answer engines and multi-doc summarization, just to kind of, because that seems like where there's a lot of connections that we can make. Then I'll talk about new work that is it's the first time I talk about it externally, so it's going to be really fun, on LLMs and multi-turn interaction. That one doesn't quite fit in reading and writing, but I'm just very excited about it, so I wanted to share. And then we'll talk about creative writing, and so basically move to the writing bit. And yeah, everything has NLP and HCI at different levels. At a high level, I think I tend to lean a little bit on the NLP side, so you'll see it, but the HCI is, and the human-centered thing hopefully comes out in all three of these parts. All right. So yeah, the first part will be on this answer engines and multi-doc summarization. And there's other authors on the paper, but the main kind of deep collaboration was with Alex, who I think maybe interned at AI2 at some point, and then Pranav, who maybe he did that I don't know, but I know we're shared friends. So the first thing that I'll begin with is how I got into all of this, answer engines and citation and attribution, which I think is very interesting. So I'll give just a brief overview of this topic. It was a paper we published at YEM-NLP last year, very NLP side. And the idea was we were kind of convinced that these LLMs couldn't quite do summarization and attribution all at once. And there was this kind of story of all you need is long context and it's just going to work out. And we were not super convinced by that. And so Alex is a core summarization person. I've done some core summarization work. So let me try to convince you in a couple of, in 2-3 minutes on this. So what we did is we weren't super convinced by the needle in a haystack experiment, where, all you have to do is kind of answer QA thing, and most of the context in the long context experiment is kind of noise, and all you need to do is find this one needle. So we were thinking actually summarization is a much better task for this long context. So we formulated a summary of a haystack experiment. What we did is we built this procedure to be able to synthesize, with LLMs, a haystack. So what's a haystack? A haystack is roughly 100 documents that are all synthetic, and each document is about 1,000 tokens long. So you end up with something that's about 100K tokens. And in each document, what we're going to do is we're going to, okay, imagine we have a global topic for all of these documents. Okay, these are study group sessions where 3 students are discussing their strategies for an upcoming exam. And then, we're going to have subtopics. So they're going to discuss study techniques, or they're going to discuss how they manage stress, or they're going to discuss the study resources they use, what apps or what, whatever, other resources, flashcards. And then what we're going to do is we're going to randomly sample these into documents, and we're going to, have these long documents. And then we're going to do query focused summarization on this entire haystack. And we're going to generate queries at the level of the subtopic. So we're going to have something okay, summarize all the top insights across all these documents about how, the students talk about managing stress. and use bullet points and cite all your sources. And because this is a purely synthetic scenario, we know exactly what the bullet points should be, right? It should be these 4 blue things, right? Like it should talk about debriefing, it should talk about daily 30-minute walk, about meditation, etc. And then, yeah, I don't know if you can. Sorry, he's one of my co-authors. I mentioned that he might. Yeah, thank you. And we know not only what the bullet point should be, but what every single document should be within that bullet point, because we have the exact mapping between an insight and what document it appears in. And so we can do this like very focused, specific, we know exactly what the ideal summary should look like for each of the insight where things should show up. And we tested out 2 different systems, long context LLM. So, you don't need retrieval, you just feed the 100K tokens into the LLMs, and then a retriever pipeline. And, we evaluate, let's see. Yeah, we evaluate in a way that's actually pretty straightforward. You have a candidate summary. We try to do this matching with the original reference insights and try to see, okay, which ones of the reference insights are present. So, like here, like there's the Pomodoro technique matches the reference insight. Like here, it mentions the column map that matches the reference insight. And then from there, if you have a matching, we can see, well, for the Pomodoro technique, we know it was mentioned in document 8, 32, 79, 83, 95. And we can see, okay, oh, here you only cited 79 and 80. So, that's whatever. It's like a precision of 50 and it's a recall of 20. So, your citation score is pretty low because you missed a lot of the good citations. So this is the final citation scores in F1 of how good were you at recovering all the documents that talked about this particular insight. Okay, I won't spend too much more time on this, but you can imagine basically we have a way to evaluate coverage, which is how good are the bullet points? Do they cover the topics that we were expecting? And then how good is the citation? The citation is like, if you've covered the right thing, were you able to trace it back to the right thing before? Do you have a question?
Yeah, I guess before we get to the results, did you do any evaluation of how realistic are these documents? That it seems like that's kind of the key.
Yeah, so the documents are definitely not very realistic. What we put a lot of effort in is making sure that the mapping is one-to-one. So basically, like you could imagine that there's a lot of, the LLM fills in a lot of details between the, going from like, okay, you should include this topic to like a 1,000 word document. And in that infill, it might introduce information that overlaps with other things, and then you don't have a precise mapping. So it might be that if Pomodoro is included just because of the infill somewhere else, then the model might be correct in citing it, and you think that that's not present in the document. So we wanted like to have very precise, like, okay, we know this happens here, and it doesn't happen, and it doesn't happen anywhere else. So we put a lot of effort on that. But the more you try to have control over things, the more it's synthetic, right? So I think like in that sense, I think it's a little bit. It's if you want, I think of it as if it can't work in this very bland situation, then it's not going to work in the real setting, kind of a thing. So it's a little bit of a, oversimplification of things for sure. Yeah.
Thanks.
Hey, Philippe, just a clarifying question again of like, so when you do the generation with citations, I was just wondering like if anyone maybe has tried like, so because LLMs do left to right, like, and it's kind of unnatural to like generate the text and then do the cite. Like, is there a change in like the coverage score if you do it the other way? Like cite the source and then write the text, or does it not make as much difference?
Yeah, no, so that's a good question. I think there's a lot of stuff you could do. I think you could also, like what you described as one. Another thing you could do is write the summary without any citation and then do post hoc citation. I think OpenScholar does some of that, like where you at least try to fix the citation at some point. So I think this is a great playground for this, because we know that the true answer, like you could really score high on this, and we have all the reference. So I think if people build these like more advanced pipelines to do this kind of like, summarization with citation, this is a great playground for that. In the paper, we just tried, autoregressive and it fails, right? Which, I'll get to. So then the results are pretty simple. It's a big table, so I decomposed it, but it's conceptually simple. So we're going to see, okay, like coverage score and citation score, right? And on like going from left to right, you'll see better and better retrievers. So like, what happens if I just retrieve random things versus like just basic vector embedding versus long embedding versus re-rank 3, which was, Cohere's thing versus an Oracle retriever. And then here, the last one is what if full means full context, meaning it's like there's no retrieval. So that's a little different, but, change of retriever versus like the rows are, change of the generator. And you can like, the big thing to me is that because you'll see the tables later, that here things are mostly blue. Like you can see that when you use random retrieval, it doesn't work well because like that's terrible. But then after that, the gains each time you increase the retrieval quality is lower and lower, right? And you'll see for the good models, like for like Claude 3 Opus at the time and things like this, the best re-ranker that's not Oracle gets 76.5, and then in full it gets 76.2. Meaning that if all you care about is having the right bullet points, but no citation, actually, if you have a good enough generator, like you don't necessarily need good retrieval for that. Okay. On the other hand, citation is like the exact opposite story, right? So here, like what you can see, without looking at the numbers, is you can see the gradient going from red to blue a lot more. Each time you improve the retrieval, you get a lot more benefit in terms of citation score. Right. And so, if citation matters in your use case, then you need a very good retriever. And because like each time you improve your retriever, you get better citation score. And my high level story of this, and if you do just full, this is like the mode without any retrieval long context, you can see most of the numbers of citation score, it's like below 20%. Only Gemini 1.5 Pro is pretty good. Yeah, go ahead.
How are you eliciting citations? Are you is it the prompt that's saying cite every source?
Yeah, it's something like, like this, summarize all the top insights about this using bullet point and cite all your sources. Yeah, it has to just like, use brackets and do citation like this.
I guess it's surprising that it can pull out the information, but not the document ID next to it.
Yeah.
Have you tried no retrieval at all? Because maybe they just know the answer.
Yes,
from memory.
That's a great question. That's what my boss's boss at the time was like. Maybe because these are synthetic, maybe the models just have that in their weights. So no, the interesting thing is like the coverage scores were below even GPT 3.5. If you don't give them the documents at all, you just say, summarize what the students say about, managing stress. They get like, more than 0, but it's like in the 30s or 40s, something like that. Was that your question?
Kind of. I mean, is it because the things you chose to stick in are the right answer or just an arbitrary set of things that you wanted to answer? So although it gets low coverage, it could conceivably know those things, right? Do you know, is there only one answer and you're scattering it correctly?
Yeah, there's a unique specific answer. So like when we generate the insights, sorry, I went very fast over that, but when we generate these insights, we make them fairly specific so that we can measure, okay, did you retrieve the right thing or are you just like throwing in the right keywords, right? So it's not only like, you can't just say Pomodoro and get full credit. You have to say something like, oh, I use this like technique where I have to split my time between 5 minutes and 25 minutes. So it's a little bit more specific. Yeah. And because of that, like you can't just, if you don't read the documents, you can't quite do it. Yeah.
What do you do with full if the model context length can't hold 100K?
So that's why GPT 3.5 is empty here because it couldn't. And then all the other models could. So we only tested models that could do 128K. And that's why we did haystacks of 100K because it was just like in the upper limit of that. Yeah.
And if you do post-hoc attribution, can you get back?
Yeah. So some people have looked at that since then, like kind of experiments of like, yeah, you have your RAG pipeline that's more advanced, like you try it out. Like what we did is super simple. We did a basic retrievers, they rank the documents and we cut out 15K tokens and we give that to the generator. So we weren't optimizing the pipeline, but that's a great question. Yeah. And then, the joint score is just like the multiplication of both. And, there's still a big gap. Like in Oracle, O1 preview threw a wrench at us. O1 preview came out just after the paper got in. So we added it in just for fun. And it does pretty good, but it matches human performance only in Oracle setting. And our argument is like human performance should not be, it's not the gold standard. Like at these things where you have to read hundreds of documents, you expect the LLM to be more systematic and good. Like we paid people to do it. They did it for like 2 hours and they hated it. They were like, oh, like this is a terrible task. Like, why am I doing this? So, this is not the upper bound at all. Okay, I'll move on because just to kind of keep it interesting. And I think this is one of the main things that's interesting in this work. So we have this paper. Pranav joined. He did excellent work this summer when I was at Salesforce still working on this and around answer engines and evaluation. And I wrote here like answer engines. What is that even? And so you can think of OpenScholar as an answer engine. You can think of RAG-based summaries plus citation, like the previous work, as a piece of the answer engine. A reading interface, like how I was introducing myself, is correct as well, and then all of the above. Okay, and in this work that we have online, there's like great qualitative work led by Pranav. That's very impressive and very fun, of very actionable insights that I recommend reading through. But then I'll focus on the quantitative part of the work, just for this talk. So here's what we did. And this is where I think like we can kind of, as people who think about these systems, kind of think together about this. So we had two types of queries, about I think on the order of 200, 250 queries at the end. And there's two kinds. There's these debate queries that were formulated specifically to be one-sided. So we didn't say why should we or should we not abolish daylight savings, but we would ask kind of the slanted version of why should we abolish daylight savings or why should we keep daylight savings. And then we had also technical queries that were written by some of our participants who are PhD students. Okay, so what did we do with these? Well, the slide goes straight into the framework, but we basically had people use 3 different answer engines. So, U.com, Perplexity, and Bing. And then that was what the qualitative study was. But then from there and from the insights, what we did is we built a framework to have different metrics about how the answer is. And like, I want to show you what are the kinds of metrics that we came up with. So here's how we decompose the problem. First of all, we're going to have, sorry, let me go back here. We kind of formulate 4 dimensions to an answer engine. There is the sources that it picks. This is on the retriever end. Then there is the answer text. So this is in pink. Then there is the citations within the answer text. And if you want, like, often sources and citations are confounded together, but we actually split it up in this work, which I think is really nice. And you can think about it like, there's the answer text on one side, there's the sources on the other, and the citation is kind of the semantic bridge between the two, right? And then there is the interface in purple. It's the 4th dimension. And so we actually built metrics around each of the 3 first dimensions. So we don't have metrics for interface, but we have metrics for the sources, metrics for the answer text, and metrics for the citations. Okay. So how do we do this? So the prereqs to kind of set things up, imagine you run a query through an answer engine and you extract the answer text, you extract the citation and the sources. So from there, we first decompose the answer text into statements. You can think of statements loosely as sentences, but sometimes it's a little bit more, a little less. And then, yeah, this is minor, but we assign an overall confidence to the language of the text. And we found that like when we label it and when we have GPT-4 label it, like the agreement on a Likert scale, the agreement is like almost 0.8, I think. So then we were like, okay, we'll just use GPT-4o. So this is like, does the text, especially for the debate queries, you'd think that a good answer would be kind of hedging and be able to say, hey, like, this is a complicated topic, there's things on both sides, but, so we can kind of score the confidence of the answer. And then we decompose into statements, like I said, and then we assign to each, for the debate queries, so the query like, should we abolish daylight savings, to each statement, we can kind of see, is it pro or con, like does it align or disalign with the initial query? And it can also not align, like it could also be neither pro or con. Okay, so now let me kind of start with the first metric. So the first metric is pretty easy. It's what we call the one-sided answer. So if you produce an answer and it's either presenting all pro arguments or all con arguments to a debate query, then you're going to be considered a one-sided answer. You're going to, be one-sided. Otherwise, if you have both pro and cons, like here, I've shown like, things that tilt on both ends, that means it's two-sided, right? And so here in this case, the one-sided answer is 0 because it's two-sided answer. Okay, so hopefully that makes sense. The second metric is a little bit more interesting. So we wanted to quantify, okay, how often do these LLMs how often are they they provide overconfident answers. And we were kind of having difficulty with that because we were like, well, maybe sometimes it's okay to be confident. And sometimes you should express doubt, right? And so the way we formulated it is that if an answer is one-sided to a debate query, it should probably not be all the way overconfident. So what we said is if your answer confidence is 5 out of 5 and you're a one-sided answer and you're a one-sided answer, then we consider that to be overconfident. And otherwise, we say, okay, you're not overconfident. Okay, in this case, imagine the confidence score was 4, then we're like, okay, then you're not overconfident. And then the last one, which is not super important, but like we calculate the fraction of statements that we think are relevant to the query. So often, you'll have in these things like these intro and outro sentences or these things that don't have any citation and aren't super important. And so we just calculate, okay, number of relevant statements divided by number of total statements. Okay. Let me show you a little bit of how, when you do just this analysis based on these 3 things, how these different answer engines behave actually pretty differently. So you can see here on the left, this is the Likert distribution of the answer of the assessed confidence of these 3 systems. And so on the top, it's all queries. Then here you have debate queries, and then here you have expert queries. And what I want you to see is that like on debate queries, you can see u.com and Bing Chat, they're a lot more careful. So they're still strongly confident, like 5 out of 5, about a third to half the time. But then they will also be just confident or neutral sometimes. Whereas, Perplexity is just like almost always very strongly confident in its language, right? And you can see it's the same thing. Like on expert queries, these systems tend to be more confident. But that maybe is okay, right? But like for debate queries, you can kind of tell some of these systems have been built to be a little bit more hedging and careful, and Perplexity isn't. And what that means is like you can see here that like for Perplexity, it gets much worse at the other thing is Perplexity also gets much worse at being one-sided. So if you ask it a question and you say, hey, like why should we abolish daylight savings? 83% of the time, it's going to reply only with arguments for why you should, and doesn't reply with arguments why you shouldn't. And vice versa. If you say, why should we keep daylight savings? It's only going to give you argument. But 80% of the time, it's going to give you arguments why you should keep daylight savings and not, right? And what that means when you combine it with this overconfident is like, we find that, Perplexity is very overconfident on average, whereas the 2 other systems, basically by virtue of having fewer one-sided answers and also being less confident, they do much better at not being overconfident. Okay, so this was like the first dimension, the answer text. Let me walk you through the bit that's about citation and sources, which I think is a little bit more interesting. So other processing steps that are needed is you have to go and take the sources, which usually you just have the URLs, and scrape their full content. And then that's one. And then the second bit is you have to also extract the citation matrix. So, given a statement, so in this matrix, each row is a statement, and each column is one of the sources. So you can see, okay, the first statement cites source 1, the second statement cites source 2, the third statement cites 1 and 3, etc. So you can kind of connect this and this. This is just like, regex. It doesn't require, an LLM or anything. Okay. And then the second matrix is this factual support matrix. So this one you need an LLM for. So for this, what you need to do is you need to basically take an LLM or take a fact-checking model like Minicheck, and then you take a statement and you take a single source and you ask that fact-checking model, is this supported by this, right? And then if it says yes, you check it. If it says no, then you don't check it. And you could imagine these 2 matrices, they should overlap, but they are not exactly the same. Okay, so hopefully that makes sense. This is like what a fact-checking model believes the citation should be, and this is like the citation that is present in the interface, essentially. Okay. So from there, here's the kind of things we can do. So first we can measure, okay, are there any uncited sources? So are there sources that are listed in the interface, right, that aren't cited in any of the statements? So this would correspond to an empty column in this citation matrix. And in this case, in this example that we drew up, there's none. So then, this uncited sources is 0, right? But like imagine if here it's cited 3 instead of 4, then this entry would be empty, and then 4 would be an empty column, and then that would be an uncited source. Next one is unsupported statements. So unsupported statements are statements that, you might cite, you might have citation for these statements, but if in the factual support matrix, and if in the fact-checking model didn't think that any of the sources supported that, then you have an unsupported statement. So that manifests as what we call an empty row in this factual support matrix, right? So if you have a statement that your fact-checking model believes none of the sources, supported, then you have an unsupported statement. So in this case, there's one. So you have 1 out of 6 of the statements that are unsupported. Yeah, and then this is what I think is key and is very interesting. So you can kind of think of, okay, so look at this factual support matrix. You can kind of think, oh, okay, like here all the documents support something or the other, support a statement or the other, right? But what I want you to see is that there's some redundancy here. So for instance, source 1 and source 4 both support a single thing and is the same thing, right? Is this first statement. And so what you could think about, like imagine this matrix is a graph. You can think of what is the minimum cover set. So what is the minimum number of sources that I need to cover all the statements in this document, in this answer that I produced, right? And here in this case, like what you can see is if you just take sources 1, 2, and 3, so the first 3 columns, you'll actually cover everything in this, like all of the statements, except the unsupported statement, which anyway, you couldn't cover, right? But like 5 is covered by a combination of 2 and 3, and then 4 is covered by 1, right? And so basically you can compute the minimum cover set. What is the minimum number of sources that I need to have the factual support, to factually support my answer? And then you can calculate, okay, well, if you only need 3 sources, but you listed 5 sources, then your source necessity is 3/5, right? So even though you are presenting to the user 5 sources, your answer only provides really effectively 3 sources worth of information in this answer, right?
Couldn't multiple sources have evidence for a single claim? Like, why is it bad to have a larger set?
Yeah, that's a great question. I'm going to talk about that in 4 slides. I'm going to make an argument for it. I think this is where it kind of becomes a bit, it becomes an interesting conversation. Yeah, I'll talk about this. But I think you'll see why one of the answer engines kind of games this, and you'll see why maybe it's bad. But you're right that you could do it thoughtfully. Okay, so those were the 3 metrics related to sources and source selection. And then the last 2 are around citation, and those are more straightforward. So there's citation accuracy, right? So you can take these 2 matrices, see the elements that are common, count those. So here in this case, there's 4, and then divide by the citation matrix, right? So here in this case, there were 7 that were totally cited, right? And you can be like, okay, my accuracy is 4 out of 7, right? And then the vice versa is the citation thoroughness. So you can be like, okay, I could have technically had 100% accuracy and cited all of this. How many of that did I include, right? So, I have 4 in common out of the 10 that I could have cited. So, you can kind of measure citation thoroughness. So now we're not necessarily arguing, you need to achieve a thoroughness of 1, right? It's not like if you can cite something, you should cite it. But maybe in some situations, it's worth having high thoroughness, and maybe in others, it's not. So we have that as one of the metrics. Okay, let me walk you through piece by piece how these different answer engines come out. Halfway, towards the end of the work, Search GPT came out in big fanfare, like the OpenAI product. And we were like, oh, we need to test this out. So we built a little scraper for it as well, and we included it. So we have Search GPT that's added. And basically, Perplexity and Search GPT are very, very similar products in the answer engine space. So they're most likely to produce these one-sided answers and to be overconfident because of this. So you can kind of see the numbers are very similar here. Then they're the highest rate of unsupported statements. So these are statements in the answer that, according to our fact-checking model, aren't backed by any of the sources that are listed, right? So you can see here, like it's 31.6 and then 47%. And then they are the lowest citation accuracy. So that's related, right? Because in their answer, they'll still have citation. But if we believe it's an unsupported statement, that means that citation was not accurate, right? And then the weird thing is like Perplexity has the longest answers. So you can see number of statements is like almost twice as much as the other answer engines. But Search GPT is not like that. Yeah. So they're kind of like on one of the extremes of this like design space of answer engines. The Bing strategy comes to what you were talking about, which I think is super interesting. So what the Bing strategy is, and Bing has changed quite a bit, I know internally. So this is like, summer 24. So this is like 9 months ago. They include more sources on average. So 4 sources on average compared to the other 3, which are like 3.4, 3.5, but they produce the shortest answers, right? So that's kind of a weird thing. And then what that leads to is that they have the fewest unsupported statements, right? Because basically their sources are bigger and their answer is shorter. So, you get less unsupported statements, which is good, but then they get the worst source necessity. So basically the argument that I'm trying to make, I think, as I think about this a lot, is it's good to have more sources, but then you need your answer to reflect the complexity of all the sources that you're pulling. It's easy to just like throw in more sources, and that will likely lead to having less unsupported statements and having less, and having higher citation accuracy, because you're going to be able to pull from one or the other. But it's kind of an easy job, right? Like you still want the answer to represent faithfully why each of these documents is included. So if you're, in my opinion, if your citation necessity goes way down, then that's kind of a problem. What do you think?
Doesn't this depend on the use case? Like you might be asking some question about like the medical literature or something, and you give the answer, which is a short answer, but then there's a lot of evidence that you want to cite, and the answer is kind of reflective of the preponderance of evidence. Maybe you don't want to read a detailed analysis, right?
Yeah, I think you're right. I think here we're maybe talking more about that web domain type thing, and maybe in domains where it kind of depends on how much time the user would spend with the answer, right? Like, I think like what's kind of come across is that at a shallow level, they like to at least show 3 or 4 sources in all of the answers they produce. But then the answer they produce doesn't necessarily pull information from these 3, 4 things. Sometimes they'll just pull mostly information from a single source, right? But still, like it kind of looks bad in the interface if you only show one source. So they'll just throw in like, oh yeah, we have like 3, 4 sources. And what we're arguing is like, that's kind of convenient, right? Like if all you're doing is pulling information from one source, you shouldn't kind of like give this like sprinkle of, oh yeah, there's 3, 4 sources here. And that feels like now, oh, this is a really backed piece of evidence, like where there's a lot of citation, when really in reality, it's all coming from one place, kind of a thing. And I think this citation, like the source necessity thing kind of gets at that. Like if you're adding a source, but it doesn't back unique things in the answer, so it's not really needed, right? And then you could kind of get away with that. Yeah, Vishak, you have a question.
Yeah, I think this is kind of related to the question, just the previous question as well, where like this trade-off that you're talking about, do you think it's kind of related to like readability or like usability of the answer? And like, so for instance, if I'm in a bar and I'm arguing about like a game, I don't care if you cite like 10 sources. And like, in that case, it's fine if you have a concise answer with fewer sources. But like, as the complexity of the question changes, you want, like you're fine trading off readability for, I don't know, comprehensiveness. Is that a good way of thinking about it then?
Yeah, I have kind of a metaphor that I've been kind of trying to come up with around this topic, which is it kind of depends what you're trying to get out of the answer, right? If the end goal is just to read the answer and then not necessarily navigate to the sources, but you kind of need to know that the sources exist to kind of trust it. So maybe the medical domain that you were talking about, right? You read the answer, but you're maybe not that likely to go into the medical papers because it's kind of out of the depth of the average user. Then maybe you're right. Maybe like the answer can be shaped in a way that's a little bit more superficial. On the other hand, if you're coming in, say into Open Scholar, and your goal is to navigate to the right paper, right? You might ask a high-level query, right? And then your objective as the like summarization producer is to help different people who come in with the same query go to the right documents that they're looking for, right? So it's kind of like, I think of this as like kind of the highway document. Like the summary helps you navigate to the right place, right? And if you have a bunch of sources in there that are not necessary, and in your answer you don't highlight why is this document necessary in the answer, then people won't necessarily know okay, if I want this piece of information, only this document has access to it, right? So actually, this is like in a few slides, I have something about this, like a mock of an idea around this, and I think you like it, Vishak.
You're saying for like a navigation use case, then this is a useful metric, but for like decision support use case, maybe it's not.
Exactly. And I think that relates to the domain thing that you were saying, right? Like not all these, like, reading interfaces like summarization with citation are for the same use case and for the same user setting. And then overall, citation is pretty low. Citation accuracy and thoroughness is low in these systems. Now, these were the free versions of these tools. So maybe, the plus premium pro versions are a little better, but like this is kind of the high level. Yeah, it was very funny. So we thought u.com did a tiny bit better than everybody else. And then when we published this, u.com was like, woo, they kind of celebrated. And we like internally we were like, well, like our finding is that there's a long way to go for everybody. But like, they were very excited, which was fun. Okay. So here's this like untested idea that we kind of like broached on through conversation. This idea of what I'm calling mini-max summarization idea, which is probably a terrible name for it. But given a query and a list of sources, so here we're not going to tinker with the retriever. What if you could write an answer draft with citation? Do this whole thing of like build the two matrices, figure out, oh, these two sources are unnecessary, remove them, do your post hoc citation. And then ask an LLM to look at it, be like, hey, we had these two sources that we just removed. Is there information in these sources that would be beneficial to this query that isn't represented yet? If so, then edit your answer to include this new information from these missing sources, right? And if so, for instance, like if say, I don't know, source 4 has a unique perspective that didn't come up in the first draft, right? You could edit your answer back and be like, and if you're looking for this and this information, source 4 has a great analysis about that, right? And so basically you can kind of like do that so that like basically you iterate over your answer to make sure that basically all the sources are represented in a way in the answer such that they are necessary, right? So instead of like kind of highlighting things that are common in the answers, like that are faithfully represented across all the sources, which then not fewer sources will be necessary. If you want to represent all these sources in your answer, you kind of maybe have to iterate in this way. So it'll kind of have this, if you can iterate like this, you kind of have a guarantee that if I've included a source in my listing and in my answer, that means that there is something that it adds to the global picture. So yeah, this is kind of an idea that's been nascent, and I haven't started working on this, though I talked with Joseph about this at WIST some months ago, but it's still there. So I don't know how you guys feel about this, if this makes sense in the scientific domain or in other domains, but this is something that I think could be cool to work around. Yeah, go for it.
This seems like a good way to maximize that metric that you were talking about, but I guess I'm still wondering if you could validate when that metric is actually
useful. Yeah. That's why I'm stuck. I think I agree with you. I think it's a little bit synthetic in nature.
It's one of the things that I want when I ask, like if I ask Open Scholar or Nora or whatever, I asked her now.
Nora's dead.
No, Nora's dead. Long live Asta. Is I want to know what, like, I want kind of a broad overview of an area, and I also want, like me personally, is I want all of the things that are important for me to read to understand like the foundational ideas in an area, and I don't care about like the long tail of like workshop papers or like minor variations on a theme or like a gold prompt, like so like the golden prompt that someone found. Like I want. Like I have a particular information seeking need, and then I have a particular like desire to be able to go beyond that, and like I want the good parts in the citation graph to explore.
This came up a lot, I think, in the study where people wanted source authority to be pretty presented, and that's not usually the case in these interfaces, right? Like they kind of play this game of like, okay, I should have three to four sites all the time, and in some cases you ask a question, and if there is a single authoritative source, right? Like you ask, say, like, can I do left turn on red in Seattle, right? Something like this. Maybe there's like a government website that answers this very well, right? And maybe you don't need 3-4 sites for this. You just need a single site to the right place, right? And so I think you're right. I think that came up a lot of like, why are you including these, and like, why aren't you including other things? And then why, like, why is the prominent thing not being presented at the top? And this came up a lot. Yeah. Oh yeah.
What about the cases for like academic reading where the claim that the evidence of supporting has sort of unconclusive? Or like you can say like 3 papers suggest one way and 2 others suggest the other.
Yeah.
In that case, like one option is like you just expand everything, add more information, and make it something like that.
Yeah. Yeah, I think we kind of had that with the one side, like one tangential idea that I'll tell you, which was interesting, is in some cases, some of the documents will present both sides of something, like kind of, or like they'll be like, they'll hedge a lot in the document, but then the one snippet that they're referred to back in the answer is one-sided, right? So imagine this daylight saving example. Some documents, some sources would be like, well, there's pros and cons arguments, but then in the answer, they would only be cited in the part that's pros, right? And then users would not like that. They'd be like, well, actually, there was a lot of nuance in the document, but it seems like you only pulled like one side of the information. So I think like if you represent a document, if you can, you have to kind of show the full picture of what that document is saying and not just like pull half of it and use it in your answer and like leave the other part kind of undiscovered. So I think that was an interesting kind of concrete thing. But I think you're right. I think like this is just like part of the answer.
So I'm just to continue kind of talking a little bit off Pau's question, where there are some questions that require more complex reasoning. And for the most part, the system, like a lot of systems, is like, we're not going to think about this. We're just going to defer to the LLM.
Yeah.
And so your system, like your approach defers to the LLM and then like pre or post hoc citation kind of, it doesn't matter because sometimes you have to reason over multiple documents to get your answer.
Yeah.
In the case of like a systematic review, which like a medical area that I'm familiar with, you have to explicitly reason about contradiction, like potentially like contradictory findings in your input.
Across different, yeah.
I don't think systems can presently do this, but that's a different story. Do you have any kind of thoughts in that direction where you need to like actually reason over contradictions? Because like this method doesn't really serve.
No, yeah, it's not.
I don't think our approaches really serve it either.
Yeah. No, I don't. I think it's very interesting. Yeah, I think like we think these models will be able to reason over multiple documents and kind of cohesively do things, but they don't. Yeah, I don't think,
They produce things that look good, but aren't.
Yeah, exactly.
They're all wearing suits.
Yeah, the surface level, yeah.
I think for that reason, this probably won't work. Like imagine your red light example.
Yeah.
You have 3 sources. You exclude the ones from Reddit where people are asking each other, can you take a left turn, and saying random things.
Yeah.
And then this thing is like, whoa, what can we add for this? Well, here's some opinions. And then just get a bunch of opinions that you excluded. Or eventually it'll sycophantically give you recursive nuance you don't want.
Yeah.
In almost all cases, because it doesn't know what kind of nuance you do want.
Yeah, it has to, exactly. I think the nuance is like, is this still something that would be relevant to the query?
Yeah, but I don't think you can do that.
Exactly.
I think only experts can do that. Human experts, essentially, for any real topic. I don't think LLMs can.
Are able to. Yeah, they'll try to gimmickly add things back in and be like, oh, there was like this interesting, very small thing, and you're like, yeah, you're wasting a lot of real estate here. Yeah, I agree. I've thought about that as well. Okay, I'll move on to the next thing, but I'm glad. I think this touched a lot of sensitive nerves, which means I'm in good company.
We all hate LLMs. Please continue.
Just searching.
Yeah.
I represent everyone here.
So this part is like, this is good. I have 15 minutes. I'll just do part 1 and 2, which is what I kind of imagined would happen. But I wanted to spend most time on part 1. But this is new work. It's like unreleased, and you're the first people that I show this to externally. So this is going to be really fun. So with my good friend Hiro and my manager at MSR. Okay, so this is a little bit different, but I think hopefully interesting to you guys as well. So, the point is, okay, LLMs are these conversational interfaces, right? We know they have user turn, assistant turn, all of that. And, they're mostly evaluated in this fully specific single turn instruction setup where, you give it the whole problem specification in one turn, and then it returns an assistant turn, you evaluate it, you're like, wow, this is great, or this is not great, and you stop there. And then in practice, people use this multi-turn ChatGPT. ChatGPT has like 400 million users apparently, which is impressive, and they're using this multi-turn, and they tend to be on these underspecified conversations that like go on over multiple turns. Okay, and in this work, like this that I'm going to present, we kind of see, okay, like do the model abilities in single turn generalize to this multi-turn setting? And the main insight we're going to use, and this is where this work is a little bit more NLP, is like pretty simple. What if we repurpose these high quality single turn benchmarks that exist, and we turn them into these multi-turn evaluations? And we're going to call that the sharding process. And let's see just quickly what an example of the sharding would look like. So this is in human eval. This is a real sample from human eval. It's a Python code generation challenge. It's from OpenAI. It's very popular in the benchmark world. And it looks like this. Okay, let's write a Python function. It's going to be called below 0. And here's a doc string for it. So you're given a list of deposit and withdrawal operations on a bank account that starts with a balance of 0. Detect if if the balance ever goes to negative. If so, you return true, otherwise false. Here's 2 examples of how you do this, right? And it's very well defined. Models like Claude and GPTs, they get 95% or something like this on human eval. They're really good. Okay, so we're going to do the sharding of this, which just means we're going to split it into these smaller pieces of the instruction that have this property that together they provide exactly the same information, but then separately they form 6 shards. So we're going to say, okay, write a Python function called below 0 that finds out if the account is ever negative. And then, oh, by the way, the inputs a list of ints that represent transaction amounts. And then, oh, let's assume that the initial balance is 0. And I didn't specify the output should be true if the balance is ever negative or false. And so you probably guessed it. What we're going to do is, instead of providing all these shards all at once, we're going to kind of provide them one turn at a time, let the model answer, do whatever it's going to do, either ask for clarifications or attempt an answer or whatever. And then we're going to observe, is it able to, since it's a human eval sample and we have evaluation for it, we can evaluate the answer that it produces. We're going to see, is it still able to get to the solution that way?
Does it get any feedback in the middle? It's just to generate stuff and you kind of ignore it. At the end of the first function, I'll just do something wacky and you'll ignore that.
I'll show you what the simulator looks like and you'll get a good sense of it. So we did this for 6 tasks. So we went all the way from PL tasks to NL tasks. So, to try to spread it. So we have code generation, Spider, which is text to SQL, math and logic like GSM8K, and data to text, and then SumHey, which is the summarization task that we talked about just briefly before. Okay, and then let me show you what the simulator looks like. So the simulator, basically, it's kind of looking messy, but it's pretty simple. At each turn, we have a user simulator. It's a GPT-4o mini in this case, which is going to decide to reveal at most 1 shard. And so to your point, how does the assistant, from there, the assistant is going to answer something. And the answer that it's going to produce could be a big discussion, one of these big long answers from the LLM. Or it could be an answer attempt where it actually has a Python function, right? Or it could be asking a clarification question, oh, do you mean this or that? Or what do you want the output to be? Or it could be what they often do also is hedging. If you mean Python, this. If you mean C++, this. If you mean whatever, right? So so we have all these strategies. And basically, if it attempts an answer, then we extract it. We evaluate it with the task evaluator. If it's correct or if it succeeds, we end and we're great, good job. And if not, then we have the user simulator look at the conversation so far and decide what to do next, which shard to reveal next. Because basically the principle is if it asks, what's the input? Then you shouldn't reveal a shard that's totally irrelevant, right? You should reveal the part of the missing information that you have. So that's why we have the user simulator, not just reveal things in one single order, but have this little LLM decide how to try to keep it correct. It is a little bit oversimplistic because we always reveal something and we have this property that if you revealed all the pieces, they're the same as the original shard. So in that sense, it's not a great user simulator. It's kind of a little bit rosy and simple, but that's the basic idea.
What if it asks a question you don't have an answer for?
Yeah. So then you kind of say, I don't know, but and then you reveal another shard kind of a thing. And then you probably guess what I'm going to say. I'm going to say, hey, the sharded multi-turn thing performs much worse than fully specified. And yeah, that's what I'm going to say. But you might be thinking, well, if you're a skeptic, you might be thinking, well, maybe it's because your sharding process is lossy, right? Maybe in this sharding thing, you lost some information and it's not that it doesn't do it, it's just that it became infeasible. So our answer to that is pretty simple. We have this concept of the concat experiment. So the concat experiment is conceptually pretty simple. So when we shard, we go from this red box to this, several blue things, which are the shards. And in the sharded experiment, like I told you, we reveal 1 shard per turn, right? But what you could do is take all the shards, make them into a bullet point format, and feed all of that in a single turn. And that's the concat experiment. We say, hey, generate the Python function, here are all the requirements, and you get the concat experiment. And so the main difference between concat and full is just the rephrasing that happens during sharding, but they're both single turn. And then the main difference between concat and sharded is that they're mostly exactly the same words, but the difference is this, like, all of it is given in one turn versus all of it is spread across these multiple turns. So it's this like kind of midpoint in between full and sharded. So we ran experiments. This is like work in progress. So we sharded these instructions in a semi-automatic way, and we run a temperature one with a bunch of these models, and we run 10 full runs, 10 concat runs, 10 lazy, sorry, it's not lazy, it's sharded now. So 10 sharded runs, and we kind of can observe like what happens, like what is the average performance. So I'm going to show you a big table, just like for SumHay. So I kind of broke it down a little bit. This is straight from the notebook. So I'm sorry for the kind of ugliness of it all. But you know, the numbers are going to look like this. You're going to have a task. Here's like the Berkeley function calling thing that's very popular. You're going to have a number for, you know, each row is going to be a model. You're going to have its concat performance, its full performance, and its sharded performance. And you can see, okay, here in this case, sharded is pretty miserable. And then you have a bunch of models, and you can see it's kind of the same. They all kind of struggle at different levels. Here in particular, the Gemini models struggle a lot, but the GPT models struggle equally, or not equally, but still a lot. And then this is the full table. You can kind of see the other tasks. And I don't want you to read all these numbers. Long story short, sharded does really worse than concat, and concat typically does pretty much the same as full. And yeah, sorry about the nans. It's a work in progress. Yeah, go for it.
I'm still confused about the sharded thing. How do you determine when the simulation ends? And
yeah, I didn't say that. Sorry.
What is the cost? Like how do you measure cost of these different things? It seems like if you were to propose an answer and user was like, oh no, that's wrong, maybe that's different costs from like a clarification question. That's
a super great question. So the conversation ends either if the model produces a correct answer. So this is here. Oops. Here. Or if you've revealed all the shards. So you reveal your last shard, you give the LLM a last attempt. By then you've revealed essentially everything you have. And then if it's still not correct, then you just stop. Yeah. So that's the first answer. And then the second point is a great point that like, hey, some of these strategies are better than others. Like a short clarification is much better than like this long discussion of like everything under the sun, right? So we actually observe, like we correlate success rates with these different strategies, and we observe exactly what you said, that like clarification early in the conversation typically leads to more success. Now, this is just what we observe through analysis, but we're using the models without any prompt strategy of like, hey, this is going to be an underspecified multi-turn conversation. We just use them out of the box like this, and this is what we kind of observe the numbers. Does that make sense? And so we haven't quantified cost in terms of like total assistant tokens generated through the conversation, but that would be super interesting. Yeah.
Or user costs.
Yeah. And and I think it's related, like number of answer attempts. Each time it produces an answer, you have to read it, right? And it's kind of a cost. But let me show you one result that I think is kind of mind-blowing. It's a very nerdy result, so it's like a bunch of box plots, so I'm sorry about that. But high level, I want you to think about this. Okay, imagine we take like this number, like say GPT-4o mini, how it does on BFCL. It goes from like 90s to 30s, say, or 40s. So imagine we had 100 samples. What that could mean is before it was solving 90 of the problems. Remember I said we're sampling 10 answer attempts per problem. So maybe it was solving 90% of them perfectly, very, very low variance. Like, you keep giving it the same instruction, it keeps solving it. And then 10% of them maybe doesn't get it and it just doesn't solve it at all. So, it gets 0 accuracy average on 10 problems, and 90, like 100% on 90 of the problems, you end up at an average of 90, right? And the question is, for the sharded case, say it gets 36%. Does that mean that it still solves 36 of the problems perfectly, and then the 64 other problems have become infeasible? So has it lost ability? Or is it the case that now it can still solve most of these 90 problems it was able to solve, but now like instead of being able to solve it very reliably, it's only able to solve it like 40% of the time, right? And so our observation here is you can see like this is like within sample. Like if you want, the way to interpret this is, what is the top bar here for the sharded mode? You can see that, basically you run 10 conversations and you take the max performance. And you can see that that's all for a bunch of these models, that's very close to full and concat performance. So full and concat tend to have very low variance. You either solve it or not solve it. You can see that in the bar. And then what you can see is that the variance of in a multi-turn conversation of these models is much bigger, but the top part tends to be pretty close to the performance, which means that they're still able to sometimes solve these 90 problems, but not reliably. Like if they make a wrong assumption at some point, they just don't recover, right? And the more you have turns, the more they might make a wrong assumption and kind of not recover. Yeah, what do you think?
I guess I'm still wondering about the sharding setting and what is challenging for the models? Like if you just had better retrieval over the conversation, like had some retriever that just collected the requirements automatically and then just fed those in at any point in time, would it solve it? You think it would match the full or...
So we have an experiment that I didn't put in the slides, which we call the recap. So you run the sharded conversation. At the end of it, if it fails, what you do is you take all the user turns. They're like, hey, here's everything again. Can you now try to solve it? And what we observe is like, I'm going to butcher the numbers, but if you were, 90% in full and 36% in sharded, if you do recap, you end up at somewhere like 60%. So it kind of course, like it recovers, but it doesn't recover fully. Now, I think what you're saying is like, as the conversation goes, if you were to recap things, what would happen? That's what we call snowballs. Like as it comes, you kind of agglomerate it for the system. Maybe that would do better. I think the point though that we're trying to make is these are like agentic things that you can do on top of a model. The point is maybe these models should have conversational capabilities as base models. Like, they shouldn't just be like, I was talking with a colleague at Cohere recently, and they were like, oh yeah, we've moved away from any multi-turn evaluation. We're just like doing single turn because like we can just have agents do the multi-turn on top of that, right? But actually, if most of the people are using these tools, why is this touching a nerve?
That was crazy.
Yeah, because like everybody's using these things.
What I just heard is it's too hard.
Yeah, I mean, multi-turn evaluation is not easy. Yeah,
Random question or curiosity.
Yeah.
So what if similar to concat, but you shuffle it, how worse it get?
Yeah, so we have the shuffle concat experiment too. I didn't put it in the slides. You guys are like on top of everything, yes. And we only keep samples during our sharding that do very close in concat, full, and shuffle concat. Yeah. So shuffle concat is just what you described. You shuffle the shards and then you feed them in an arbitrary order. And we do that 10 times so that like you get a bunch of different orders and you have to maintain performance. Otherwise, like, our sharding didn't go well. And so like, that's not an interesting experiment to run. Yeah.
Have you looked at any of these samples on the bottom of those bars? Is the problem the model is adding irrelevant details or noise during the multi-turn?
Let me show you why we think this is happening. Yes, a great question. So one thing that's weird, and so not all of these problems have like answer length being important, but two of them, human eval is Python generation and Spider is text to SQL. And what we observe is that in the sharded mode, even when you get to a correct answer, it tends to be longer in number of characters than in full and concat. So you can kind of see this. This is still a slightly smaller sample, so like the numbers are not like perfect, but you can see every time the red bar is bigger, which means that like even when at the end of it gets to a correct solution, it's kind of a shittier, longer solution with a bunch of stuff in it, right? Because what happens is like, the turns go, the situation is underspecified, so it makes assumptions. It's like, oh, maybe I should use a for loop instead of, like at this stage. And then you reveal something else, and it's like, oh, actually a while loop would have been much better, right? So in full and concat, like it would have figured that out all at once. But then in this sharded thing, it's going to tend to stick with what it's already done and try to kind of like build on top of it, which means it ends up, kind of taking wrong turns because it's in underspecified scenarios. And instead of trying to recover, it just kind of like builds on top of it, right? And it ends up having these kind of longer solutions. Yeah.
That sounds like it needs to kind of be reluctant to actually deliver any kind of solution until it's like understands what's going on.
Yeah, that's what we observe is like in conversations that it tends to clarify or like kind of have shorter turns at the start, it tends to do better, these models. Because basically the more they talk at the start, the more they might lay down assumptions that aren't defined by the user, that might detract them, right? That might detract the model. Yeah.
Dumb question. Have you considered just ignoring the model output for like future turns? Like give it like the user input.
Yeah, so that's almost the concat experiment, right?
Almost, but the user simulated user has reacted to what the
that's interesting. I hadn't thought of that.
So it's actually been integrated to some.
Yeah, to half of it basically. Yeah, Cool. This is, I think, the last slide I'll present is like basically as the conversation goes, you can see the average length of the answer attempts go up. So the Python function is getting longer and longer. And it kind of like, it kind of points to what you were saying. Like, so we looked at a lot of conversation, yes, but you can kind of observe that it'll pick a library to use, or it'll be like, oh, I'm going to join on this table in Spider, right? And it won't recover. It'll kind of like try to keep that. And so even if these models are kind of gymnasts and they figure out how to give you a good solution, like a functional solution at the end, it tends to be qualitatively worse because of that. Yeah. But yeah, this is the last slide of part 2. I know our time and yeah, it's like, okay, like there's kind of this degradation of performance on these generation tasks when you go to multi-turn, and it's not a loss of like abilities. The models can still do everything, just sometimes, and that's bad for users because reliability is important. And well, yeah, when they get lost, they don't recover. Yeah. So yeah, thanks for coming. I hope some of this was interesting and fun. Yeah.